It's nice to be here again. So thanks for coming to my session. I hope it will be interesting topic for you. So today we are going to speak about the security stuff, a little bit the unknown areas of Android. So mostly the CTFs, and probably some of you might know what the CTFs are, but yeah, we'll cover this. So, and how we can manipulate the Android apps on a different level to get the results we want. I'm Mirab Tatagutalia. I'm Android GD and also the Android lead at TNet. So it's we are building the super app for the local market for now. So this kind of challenges, like the security challenges coming to our way, it's very active, and we as developers, we always need to improve something in our code base and also like to defend at the various levels. So first of all, before we move on, have you played CTF challenges, like no matter like mobile or what? Okay, quite a few folks. So yeah, so CTFs are like quite fun, and it gives you the ability to basically challenge yourself with different tasks and find the vulnerability maybe in the existing system, or like the understand how the system works, basically to break it and define the flag. But more on that a bit later. First of all, let's review the common Android vulnerabilities and like see the statistics and also the types of security testing, and then solve one of the CTF challenges which I literally solved before coming to Android Makers just for this talk. So it will be interesting to go down to bits and see what's under the hood. So first, Android vulnerabilities are like a very common topic as for Android developers, but sometimes we still underestimate them and like write the application in that way that the users might not really understand what's going on there, but other developers and like malicious actors can somehow exploit the application on the user's device, and this might leak the sensitive data or like do some actions on users' behalf, like they're in undercover. So one of the common vulnerabilities, here's the list, like for example, the insecure data storage, improper input validation, inadequate supply chain security, and this one is the new one in the OWASP top 10. So this list is not like it's not a full list, but it's in OWASP top 10, and OWASP top 10 is like the basically, as the name suggests, top 10 vulnerabilities and how we can defend against them, and it is updated regularly. So this year, 2024, we got the new update, and this new update includes the supply chain attacks and how we can secure ourselves and our apps from that. Yesterday at Hallway, George had a really nice session regarding that, how we can protect our Gradle builds and like Gradle binaries from this supply chain attacks. But basically, there have been many examples in probably JavaScript world, in different platforms where we thought we were getting the correct binary, but actually with some kind of typo or whatever, we got completely different binary, which was a malware or something like this. So this still applies to Android, even though we pull everything from Maven. Like we still need to be sure that that's a correct dependency. So, and many more. So please refer to the OWASP top 10 to see the updated list. And this is not the only thing that OWASP offers. There are plenty of other stuff there, so we'll talk a bit later. So let's do a quick recap of what's happening in the world, like what we are going against war, and the overall attack surface. So this is only for one quarter, like third quarter in 2023, according to the Kaspersky, which is like the antivirus and the anti-malware software. So they reported that more than 8 million mobile malware and like all these small other categories were blocked by Kaspersky, only by Kaspersky, and only in one quarter, so quite scary number. And out of all those numbers, 52% was the adware. So adware can be like the very, very vague term, but basically hijacks your, like the screen, shows you the basically advertisement, and basically application is useless most of the times. And to protect against this, we need like to always download our applications, in that case APKs from the trusted sources, and also Play Store is actively putting some measures to block those kind of applications from the Play Store. But yeah, you know, like it's like a cat and mouse game, so there's always some innovation coming from both sides. So just as you developers know how to build application and where to get it, probably this doesn't really apply to you, but your users should be informed how to download and where to download even your applications. So moving on, this graph displays the number of attacks targeting the according to the the number we had, and also same time this graph shows the how like the malicious packages found, and it's basically again mirroring the uprising trend which Kaspersky showed in the third quarter. But this is like historic data from 2022. Of course, you can refer to this. I'll share the link so you can refer to the original source and read the full report. So there are popular types of mobile malware, of course, because it's a huge area and developing rapidly. So you might see mobile adwares, banking malwares, which is very, very hot topic, and you might not see it like in daily life, but banking malwares in a while like really affecting certain countries or certain group of people, or like the very specific apps. So if you are not targeted by it, really good, but the entire country is targeted by specific banking malware or like the very, very specific applications, and it's like very scary because even though Android is really improving and blocking, for example, drawing over other apps that you need specific permission, background, foreground services, like everything need to be declared in a Play Store, there's still many applications and somehow like bypass this on a user device or somehow repackages application and it acts as the original application, but underneath it is some kind of malware. The mobile ransomwares still on the rise, so we somehow had this trend a few years ago. The ransomwares was everywhere on the computers, especially on the Windows, but hey, on Android we also get the ransomware. So it's a very active battle going on in the world, and also, of course, spyware. There are lots of zero-day exploits that work like for the very specific user group. So you might not be targeted by spywares, but there are many, many people that are like specifically targeted with zero-day attacks with this kind of spywares. That it means there were a few zero-day attacks that actually took over the device, the operating system, by just clicking the notification. So this kind of crazy stuff, and yeah, this affects to some human rights activists in certain countries and journalists and so on. So yeah, it's a very scary world even for the mobile malware. All the resources you can find are here, so you can scan a QR code and go to LinkedIn. Statcaster, and there are like the other links as well, which we'll see later in the slides. So yeah, just make sure to scan it for the future. So there are some GitHub projects as well. Okay, so let's focus a bit on testing. So here are like the few areas I want to focus today, and like to do a small mental note, because this will be needed in the end. So what we have here in the testing area. So it's not the quality assurance testing, that's proper security testing, and we have like the few different directions we can take, and usually those are working like together. You can't really pick one and say, hey, I'm doing only static analysis and I'm doing in that area. So first one is, of course, like probably all of us are doing, or like they at least have done in our lives, like static analysis and static application test, security testing. And basically, this is when you even decompile the Android application, open the APK, like how it's a JEDEX or like APK tool, and see what's written there. So basically, do or even use the tool on the CI server to, to basically scan the code against some malicious code or like the some security holes. So static analysis, many tools is doing this. The second one is the composition analysis. This is basically doing like different things all together, and like also to connect the database and like the testing everything all together. Third one is, of course, like used everywhere, that's a fuzzing. So basically generating the random inputs to see how we get the different outputs and like the monitor these changes in certain rules, like you can set some kind of boundaries. And the last one is the dynamic analysis, which is quite popular in the Android world, and we have like lots of tools to achieve this. One of the most popular one, probably you've used it, is Frida, which basically allows you to hook into the running application and change even the class paths, change like query the current state of the memory, basically do everything in the runtime, bypass the root check detection, bypass the pin code, basically everything in the runtime. So why those different security testing types are needed? Because for our application, like everything happens at once, and you can't really use one type to achieve the result. Like we will see this later in this CTF challenge, that if you choose the static analysis, you might see like 70% of the picture, but the remaining 20-30% is what really like opens the whole picture, opens the whole intent of the application, and plus there are like many hidden things going on. Probably the malware will activate only at a certain hour at night, probably after, maybe even if you install the application, it will not activate for the first 7 days, and then it tries to do something on the device. So like you need these fuzzing techniques, static analysis, everything together just to understand what the intent of the application. So, and on the other side, from the developer perspective, we want even our applications to be tested, and of course this kind of job sometimes offloaded to the red team or pen testers or like some kind of companies our company hires just to deliver the full report, what is needed to change in the application. But we as a developers want to understand what's really going on under the hood. So also there are many other companies which provide tooling on a CI/CD level, so you can install those tools, of course the commercial tools as well, that can scan your application or like to monitor the applications on the emulator and so on. But there are limitations of testing, of course. First and foremost is like they are false positives, and this is like very obvious for the static analysis tool. Even if you look at the linters are doing the same. They do the static analysis. But what you get is that sometimes linter is missing the context, and you have the false positive, and sometimes you need to suppress the warning just to make it pass. Yeah, of course, they're missing the context, and also they are language dependent. It means that they really need to understand the syntax of the language to really make them work. So you always need to pick the tools that works maybe for this language and also that language. Otherwise, you need to invest in multiple different toolings. On the other hand, dynamic testing is not dependent on language at all, but is dependent on the time constraint. So it is very slow, like time consuming from the developer side. Even if you automate the stuff, you still need some manual intervention, and takes a lot of time and resources. Sometimes emulator is not the right thing to test on an emulator, right thing, and you need very specific devices and very specific conditions. And of course, manual interaction is like a limitation of almost every tool, at least on a initial setup phase. So you remember I mentioned OWASP. So OWASP also provides the security checklist. Basically, what kind of conditions your ideal application should comply to, say that, hey, my app is secure. So there are different tools, tests, and techniques to basically achieve this. If you, this is in the resources as well, like the link I shared, but you can also visit directly to github.com, OWASP, and OWASP MESTG. So basically, it's a mobile application testing guide, and it gives you a huge Excel file, so you can go through and actually test the different aspects, how my shared preferences are saved, where those are saved, what is the access type, like the users can access or someone outside, and so on. The second one is the different tests, how we can, so we might know that there is a problem, but we don't know how to test it, or we don't have the techniques. So this resource on the OWASP website, the OWASP website gives you exactly this. So tooling, the description of tools, how to use it, when to use it, what tests we need to actually pass, and what techniques are there, maybe hooked to the memory or to the stuff. So I absolutely recommend to check out this resource, and this resource is available in PDF, in the GitHub wiki section, so everywhere. Let's talk about the CTF, which is basically means capture the flag, and it's one of the most important part in the security researchers, pen testers, and just a hobbyists career, because most of the times CTFs provide the challenges that are in a limited environment, in a controlled environment, but at the same time we'll learn so much about the exploits, language vulnerabilities. Maybe imagine a situation when the certain language, probably let's say PHP, have some vulnerabilities which is known only for the PHP, but you need to know this to to protect against those kind of vulnerabilities. So the same goes for the iOS, Android, so you need to know different holes, the areas you need to cover the surface. So basically the CTF, the controlled environment, and the gamified experience gives us all these different, covers the knowledge gap, and then we can fix our software. So as I mentioned, it's gamified experience, and basically those are puzzles, and you should basically hack it. And as a hacker, you should use different cybersecurity skills to first exploit the vulnerability, see what vulnerability might be effective against this kind of task. Take a flag. Flag is basically the string in a certain format that is the actual answer. So you submit a flag, get the points, and hooray, everyone is happy. And there are like the competitions of CTF, there are lots of CTF competitions, CTF teams, which basically try to do this kind of stuff. And on a very advanced level, so these CTF challenges are like real world examples, so you really have to like exploit the system and escape maybe some kind of sandbox or whatever. So it's like the crazy stuff is going on. And then mostly you see the write-ups. I've also done few write-ups on my Medium blog. So it basically you write like how you solved it, which also make it easier for the other folks to understand the mechanics of these challenges. So what I have for today is I'm not say it's a hard challenge. It's like the medium levels challenge, and I want to go through that challenge and how I solved it, and like also give you the glimpse of how normal CTF challenge might look like. So in the future, you might want also to contribute to that side. So before we start, we have like, as I mentioned, different kinds of like types of CTF challenges. There are cryptography, of course, which is like basically related to cryptography, and you have to basically hack that and like understand the vulnerabilities of different algorithms, or like how to reverse some types of algorithms, and like basically find the key. Web exploitation is like the huge area. Binary analysis and reverse engineering, super interesting stuff, and you'll get to know different CPU architectures, operating systems, how binary works, and like lots of different bits of these layers, forensics, just to maybe you have the dump of the Android system, the whole storage, and you have to find something embedded there that will give you the result. The mobile security, of course, Android iOS. The cloud security, steganography, it's like a bit niche, but the example of this would be you have some kind of image, JPG image, and you have to find the flag. What it does means that somehow you have to find flag in a JPG, maybe search for the binary inside the image, or maybe scan for the pixels and track the colors of the pixels, like, and you might find something in between. So yeah, it's crazy and very niche type, but quite interesting. And like, of course, exploit development and open source intelligence. Basically, OSINT said it means that using all the open source data needed to do the investigation and get the result. So this is just a Hack the Box website, quite popular website. It also provides the CTFs, but those challenges. And this example, it's called so it is marked as a medium level, gives you like 40 points. Like, who cares about the points at this point? Yeah, just you can download the APK and start solving the challenge. Here's a small description, only this description, like the malware forensic lab identified a new technique for hiding and executing code dynamically. This already gives us a clue that, hey, we really need static analysis plus dynamic, so we need to execute it. And samples that seems to use the techniques just arrived in their queue. Can you help them? So basically, hint is there that we need to execute this application as well. But yeah, it really depends how we want to approach this problem, because everyone is different. Everyone has a different kinds of like knowledge in certain areas of Android. So for me, I spend a lot of time in static analysis just to understand how everything is written and it can work, and then I just go to dynamic stuff and try to only do what's needed. For some folks, it might be vice versa. The dynamic stuff draws the most of the picture, so it really depends. So I have a very limited set of tools, and we don't need anything more like other than that, but the tip would be to have your lab ready on your machine, whatever you have, but just use the, at least like the virtual environment or like the USB bootable Linux or whatever. Just don't install everything on your machine altogether, because then you need to execute those stuff there, and virtual machine is the safest to this at this moment. So yeah, prepare your lab. Just your lab is like, if you would care about your physical lab or a physical thing, the same goes to the virtual lab and all the tools in your laptop. And just as you care about your development tool and environment, you should do the same for these tools. So there are plenty of tools. Probably you'll need almost like 60, 70 different tools for all the different kinds of CTF challenges, and you should learn them. It's like you would use the hammer and other kind of tools, but yeah, like there are very specific tools for very specific tasks. But those tools are like very, very generic, and we can use them right now. So JADX is like basically Java decompiler, and it has also GUI support. APK tool is basically decompiles APK and also recompiles. So basically what you can do is like decompile, you'll have some smally codes there, like classes.dex, which you can also modify. And as you do more and more this kind of stuff, you'll get used to read not only the bytecode, but the smally opcodes. So at some point you can edit the smally opcode, do some kind of functionality, repackage your application, and boom, you might have some extra features, like not indicating anything, but sometimes you can bypass some restrictions on the applications locally, educational purposes. And then you have the IDA or Ghidra. IDA is IDA Pro is a paid version. Ghidra is open source by NSA, yes, and it's quite good. And Frida is basically the free version to hook into the running applications on Android and iOS and macOS. You have Python and JavaScript scripting capabilities, so basically you can do whatever you want in the running application. But probably we don't need this today. I will give you the example where we can use it, but I will not use this in this example, like just to solve this. So just to recap for the folks, those are two layers in the Android where we can execute our code. Most of the times we write our applications for the JVM level. So the Android SDK, the compiles against like the application runs on the JVM. And then we have another layer, like native layer, what we have the NDK for, just to run our code on this native layer. And probably you have used this for various reasons, but many other applications use this for image processing, for like the graphic stuff, and so on. So it's not very common, but yeah, there are many use cases. So yeah, we will need this, and I will have another slide to remind this architecture, but basically, yeah, two layers where we can execute the code. So first, download the APK, and I installed it on the emulator and click it, and nothing happens. So those are like potato quality GIFs, but bear with it. So I wanted to do this live, but actually my IDA Pro broke down. I could not make it work, so I'm glad that I recorded the screens just because I wanted to write the blog on the Medium. So that's how I managed this talk. otherwise, I should have picked another laptop. So anyways, application is not working. Next step, let's decompile it first. That's very trivial. So let's see what's going on in the main activity. So what we have, like, let's see, like a bigger picture first. So just a normal on create. We have the, okay, it's getting the bundle. We have one variable, something like it takes the path dynamically, the data folder path, And then we have this interesting part that if extras equal null, then finish the activity. It means that by default, when you open from the launcher, it starts executing on create, but then sends the finish signal immediately. Interesting. Another branch is that if it's not equal to extras not equal open and sysam, then finish. That's interesting. And in all the other cases, proceed. And then if it proceeds, there's like the background setting background color and like calling the system service and like does some weird stuff. But more on that later. So okay, so now we are hitting already stuff where we need to do something dynamically, like basically just to execute the application. So what I do, I just craft the intent, so you can do everything from the ADB shell. So ADB shell, like main action, of course, just the open with open and sysam. So because it was ignore, like see, from the previous, it was ignore case. So basically you can pass this. Basically you need not to pass the exact same string. You need to have the uppercase somewhere in the string, not the same case, and then the package name and main activity. So okay, I do this, and application basically opens, and we see like this huge window as it were in the initial script. So that's it. Okay, what's next? We see this click me button. Of course, there's a red button. I click it, and it closes the application. Nothing happens. And of course, we are the developers. We saw in the initial script, that it was the system service window and add view. So in that case, it means that it wants to draw our other applications, and then we check the Android manifest and says, system alert window. Interesting. But on the Android, you need like to request the permission for that and enable it from the settings. So I enable it from the settings, and yeah, like run it again. So it closes. I go to the application settings, display over other apps, enable, open with an intent again, click it, hey, there's some kind of dialog opens. Okay, next step, this is dialog. Don't mind these white squares, it's a bug, but yeah, like just ignore it. You have some kind of dialog and it immediately says, so we have to do some kind of bitwise operation on some kind of input to basically sortify. So I enter any string and it just does nothing. Interesting. So let's continue the debugging. So here we have the alert function, and in alert function, we have this alert builder, which on click does interesting thing. We have the main activity, file path prefix, and the answer, which we pass to function A. Hey, do you remember this file path prefix that was assigned in the runtime on create, the data directory? Okay, we know that, but the answer is what we have in the input. But what is the function A, or the method A? So we go to the function A in the main activity again, and we see that it's native function. So it means that it loads something from the NDK layer, that the image I showed, like the native layer one level below. And in a static block, which means that it executes immediately on a class initialization, we have system load library default. So we refer it with a default string. So yeah, the answer is build config flavor. Flavor is empty, so initially it's empty and assigned after the input. File prefix, we already know that it got the application directory. Okay, so it means that we have to go down one layer below, according to this scheme. Okay, we somehow get the IDA-Pro or Ghidra running, and also decompile with APK tool, but lib's directory look like this. lib default SO, lib native lib SO. But do you remember we actually referred default in a system load script? Here, default. But we don't have default here. We have lib default and lib native lib. What's happening? So basically, in JVM, you have two different ways to link native methods to the Java code. First one is to call native function in a specific way that JVM can find it. Or there is like another way, JNI register natives method, so it can like register native methods with a different name and the class passed as an argument. So basically, this is our case. So there are two ways to solve this. First one is using the Frida, which I mentioned dynamically. So you look up, you hook the Frida to the running application. You write the script. What are the native libraries that are like dynamically linked, and you get the name which native library is linked to the default. But you have to write the specific script for it. In that case, it's like very straightforward because like we have two libraries, we can check both of them very quickly or scan them, at least extract the strings from this. Even if you run strings default, libdefault.so, it might give, like, it will return on the Linux, the Unix-based systems, all the strings in this binary. So you might even get the key from it, but it's not the thing here. So we need to go deeper. So we have already eliminated multiple different areas where we don't need to go. Next step. So the first one I already mentioned. Second one, let's check the file. I opened libnative.libso, and it immediately says nothing here, just finish the program, that's it. So I'm not interested into this native file. Moving on, so we have left libdefault.so. I decompile this, and we have few interesting functions here. And as I mentioned, in GNI, you have multiple ways to hook this dynamically, and we saw this. So it hooks to main activity automatically, this libdefault.so. So that's why we had this link, so it knows also in which activity this default implementation is linked. So we have GNI onload function. Yeah, that's for it. But also on top of it, we have like the crazy names here. After the compilation, we can rename those to make it like more human readable format, but just for the sake of simplicity, just follow this path. So we find that double clicking on this function, we see the code with two parameters, and probably those are these two parameters we had. First, file path we had, and the second, the answer. Okay, let's move forward. Double click it, and we see this decompile stuff. But all the interesting stuff starts here. See? There's a XOR operation, like a bitwise operation, and the original application actually mentions it that we need to XORify, like this, some kind of string. Interesting. So we have variable L, and we have variable M here, and A2. A2 is basically the result we are getting. So, and it's like from the array, like we have to access different characters. So it means that first element of bitwise XOR, the second element should equal the M. So if we reverse this, basically it means that we can reverse XOR and get the same result. So, interesting. So let's check L and M variables. We double click them, and we see that somewhere in the memory, those are already declared. So we can create the hex values out of them, just adding the 0x in front of it. And we have some kind of values for L and M, the same lengths. And like the rule is that we can like sort them, like do the bitwise operation, just to get the result what we wanted. So just a plain dumb Python script. I'm not the expert here with Python. Just iterate over this array and just do the bitwise operation, append to the result, and print the result, and it says floating with a 0 in the middle. So that's our input. Wow, but that's not a flag. This is our input. So we need to enter floating in the application just to see the result, the flag actually. So that's nice. That's nice. The floating. Okay, enter the magic key. But application doesn't do anything. So here is a demonstration just to make sure we are on the same page. I enter floating. Oh, nice. Here, floating. It closes the dialog. If I enter anything else, it just resets the dialog, even not closing. But the correct answer just closes the dialog, nothing else. So, as it seems that we need to read more code on the native layer because nothing is happening. So, if we continue reading the code, so we see that there is like f open, which means that we have to open some kind of file, and then we have write permissions there. And up the line above, we have this the character h, which is being used later in the script. What does it mean? It means that the first parameter we passed, the actual path, data path, is being used here, and then it creates some kind of file named h in that directory. And it's like fully dynamic. You can't really get this result from the phone if you are not running the application. So basically, in the app directory, you'll find h once you enter the correct string into the Android application. Okay, I did ADB pull from the app directory and then run the strings command on h. As I told you, if you have like this this command, you can basically extract all these things. And here it is, the hack the box prefix, and that's a whole flag. Then you submit the flag, and hey, you just solved your Android one of the CTF challenges, and so nice. So it's a real nice feeling. And at this level, if you are not experienced into this, you learned multiple things: how to decompile the app, how to decompile the native layer, how to understand basically disassembled code, and see static versus dynamic analysis, see how it plays all together, understand how XOR is working, and maybe write a bit of Python script, understand like basically reverse the logic, and see like the picture one level below. So even though it's like the middle level challenge, I would say it's at the beginning spectrum of the medium challenge, because like some challenges are much more interesting and harder, but this one was pretty fun. I enjoyed them much, and yeah, I wanted to present this kind of challenge for you at the DroidCon. So we as a developers now we have to think about what we're doing with the application, and even if we put our secrets in a native layer, it doesn't change anything if you don't protect it well and like to do like the proper stuff you need, like all the best practices and so on. So if you are interested to do more, you can find the CTFs in many other places. CTF Time is a good resource. Basically, it tracks the CTFs all over the world, online challenges, everything, and you can train yourselves. There are some challenges already, and the Hacks the Box, like the huge resource on that, and many more, of course. So, like plenty other resources. And even though it's like mobile challenge, it goes beyond the JVM layer, and that's the beauty of the CTF challenges. All the resources are here. You can just scan this QR code and get the resources to the specific websites, and also like the blogs and stuff like this, so you might use it. And that's the end of my session. So thank you very much. You can also send the feedback here, and you can find me on Twitter, LinkedIn, Mastodon, whatever. Thank you very much.